In this video, we will discuss what gravity can do. Gravity can bend light. If a large collection of matter lies between the Earth and a light source, the path of the light curves as it travels towards us, creating smears, multiple images, or even a complete Einstein ring. This is known as gravitational lensing. As light travels past a massive object, it is forced to travel around the curve and its path becomes bent. The image here shows an Einstein ring which is formed by the deformation of light from a source. Some bacteria grow even better in microgravity. Colonies of bacteria grown on board a NASA space shuttle behaved very differently to identical bacteria grown on Earth. They stuck together in shapes never seen on the ground and managed to survive in much higher densities. Did you know that extreme gravity can even tear whole star systems to pieces? When a massive star dies, it leaves behind a remnant core with so much mass that it collapses under the force of its own gravity, creating a black hole. Black holes have such a strong gravitational pull that not even light can escape through it. They can tear nearby stars to pieces and completely shred their component atoms. In zero gravity, a candle's flame is round and blue. Yes, a candle can burn in zero gravity. However, the flame is quite a bit different. Fire behaves differently in space and microgravity on Earth. A microgravity flame forms a sphere around the wick. Diffusion feeds the flame with oxygen and allows carbon dioxide to move away from the point of combustion, so the rate of burning is slowed down. The flame of a candle burned in microgravity is an almost invisible blue in color. Gravitational force is infinite. Gravity might be the weakest of the four fundamental forces, but has unlimited range. Its strength decreases rapidly as objects move farther apart, but its reach is theoretically infinite. So 90% of the Earth's gravitational pull is felt in international space stations. You will feel weightless at the center of the Earth. Hypothetically, if you dug a tunnel from one side of the Earth to the other and jump in, you would accelerate towards the center, reaching a speed of around 7,900 meters per second. When you reach the center, you would be momentarily weightless, but inertia would continue to carry you through the tunnel, and you would then decelerate while you exit, emerging from the other end 42 minutes later. Jupiter's gravity will eventually cause Mercury to crash into the Sun or be ejected from the solar system. Jupiter is the most massive planet in our solar system, and therefore the gravity of Jupiter is most intense. Its gravity is 2.5 times what it is here on Earth. In the 1990s, Jupiter's gravity tore apart a comet, Shoemaker-Levy 9, and pulled the broken pieces into the planet. Jupiter had actually captured the asteroid between 20 and 30 years prior to the impact, and it had been orbiting the planet since then. In 1992, the asteroid entered Jupiter's limit and was broken apart by the planet's tidal forces. The asteroid resembled a string of pearls until its fragments impacted the surface of Jupiter. Did you know that the Earth's gravity makes it impossible for mountains to be taller than 49,000 feet or even 15 kilometers? Astronauts do not consume sodas or carbonated drinks in space. Why? Because the lack of gravity to separate the fluid and the gas in the stomach leads to a kind of vomiting called wet burping. On Earth, the gas and the liquids in the stomach separate and the gas rises above the liquid. So when you burp, you are just releasing the gas. In space, there is no mechanism to keep the gas and liquids separated due to lack of gravity, so burping can result in fluids being expelled. Food does not taste the same in space. Isn't that interesting? Without gravity to pull fluids down, astronauts' sinuses get clogged up and they cannot really taste much of anything. These are some of the most interesting facts about gravity and what gravity can do.